Hello everyone, this is Mrs. Crandall and I will be talking about factoring, specifically when we have trinomials where a is equal to 1 and when we have something called a difference of squares. Again, as a reminder, we always need to check for a greatest common factor. I've actually completed number 1 for you by the grouping method. So found the two numbers here, which would be -6 and 4, and then factored it by grouping, and then ended up with the correct answer of x minus 6 and x plus 4. So when I teach this in Algebra 2, I have students really pay attention to the two numbers that we found in our diagram and the two numbers that ended up in the factors themselves. And as it turns out, we do a few of these problems, and as it turns out, it always actually works this way. And it works this way specifically when a is equal to 1. And lucky for us that a lot of times when we're factoring, a is 1. Not always, but a lot of times it is. So we get to the point where we can just use the shortcut. As soon as we find these two numbers, then we can just write them into our factors. So let's do that actually with number 2, but there is one additional step that we need to do, and we need to factor out a 2 from the very beginning. So we get 2n squared minus 10n plus 9. So we need numbers that multiply to 9, but add to -10, and that's going to be -9 and -1. So they multiply to a +9, but the two of them together add to -10. And using that rule that I just told you is that we're actually ready to write our factors, and we can say that that's n minus 9 and n minus 1. And then don't forget the 2 in the very front, and that is it. We're done. The other type of problem that I want to show you is something called a difference of squares. So you can actually attempt these problems by grouping what we did before. But there is a similar pattern that emerges here, and I'm just going to go ahead and tell you what that pattern is instead of working this example out completely. A difference of squares has to have several things. The first is they have to be two perfect squares. So two perfect squares. Meaning that if you take the square root of each term, that ends up being a nice number or variable. Meaning, if we take the square root of 4, we get 2. If we take the square root of 3, we get something else. It's called an irrational number, but we don't get something that's rational. And then the other thing is that it needs to be separated by subtraction. It's not called a sum of two squares. It's called a difference of two squares. And there are reasons why this we can't factor a sum of squares. Really the main reason why we can't factor a sum of squares, basically if this was a plus, is that it just doesn't factor. It's not possible. When you set up the problem, you can't find numbers that satisfy that diagram that we've been looking at. So the pattern is so you have two perfect squares separated by subtraction, and what it always factors out to is a plus b and a minus b. So essentially you take the square root of each term and put them into this format. So the square root of 4a squared is 2a, and the square root of 25 is 5. So that's going to be 2a plus 5 and 2a minus 5. Again, if you check that, multiply it out, you end up right back at 4a squared minus 25. It's helpful especially to know this pattern when you're dealing with multiple variables. So they are both perfect squares, still fits into that pattern. Take the square root of x squared, it's x. Take the square root of 9y squared, and it is 3y. So this factors into x plus 3y and x minus 3y. Similar to solving, we're going to make sure that it's set equal to 0. We're going to check for that greatest common factor. And what we have a greatest common factor here of 4. Numbers that multiply to -2 but add to -1 is going to be v minus 2 and v plus 1. Okay, and that is all equal to 0. Now, I told you before that we set the factors equal to 0. Well, when we set 4 equal to 0, that doesn't make any sense, so we actually disregard it. We only set the factors equal to 0 that contain a variable. So let's do some algebra here, and we get v is equal to 2. I guess we're doing algebra in all of this, but more algebra 1 type style algebra. And there is our answer. Same thing here. So we use the shortcut a equals 1, and we set each piece equal to 0. Here we can use a difference of squares. So we have 5x plus 3 and 5x minus 3, and set each one equal to 0. Minus 3. Subtract 3, 5x is equal to -3, and x is equal to -3 over 5, and then this one is going to give us positive 3 over 5. So those are the answers. All right, that's it for this video. And keep practicing. I will attach a practice worksheet to go over problems like this if you feel like you need the extra practice.